In this video, I'm going to go through how to find out if two lines are parallel. Now, to be parallel means that the lines have the same gradient, and it means that no matter how far you go in this direction or this direction for each of the lines, they are never going to touch. They're always going to stay the same distance apart. So we're going to prove that using our gradient formula, which I talked about in another video. So we're going to use this. So we first need to find the gradient of our lines to find out if they are parallel. So if we're looking at AK, which is this line here, you've got the gradient for that, which we're going to find by doing y2 minus y1 divided by x2 divided by x2 minus x1. So A has the coordinates 3, 6, negative 3, 6, sorry. And K has the coordinates negative 5, 3. So A is going to be our x1 and y1, and K is going to be our x2 and y2 there. So we put that into our equation, and we get 3 minus 6 over negative 5 minus negative 3. Which gives us negative 3 over negative 2, which gives us a gradient of 1.5. If you want to know a little bit more about how to do that, please look at the video on finding the gradient. So that's our gradient for that one. We need to find the gradient of the other one to prove that these two are or aren't parallel. So we're going to do DG next and find out if DG is parallel to AK. So D and G have the coordinates negative 2, negative 3, and 0, 0, x1, y1, x2, y2, and then we do 0 minus negative 3 over 0 minus negative 2. Which gives us 3 over 2, which is 1.5. Now you can see that this doesn't look quite the same as this one when you fully simplify it and turn it into a decimal. So a fully simplified fraction or a decimal will show you that these actually have the same gradient. So that means that AK and DG are parallel. And that's what that line, that arrow there along the line means. If you've got two other lines like this, and they're also parallel to each other, you just do a double arrow to show that those two are parallel to each other, but not parallel to these two, because these only have one arrow. For C and H, we've got 4, 2, x1, y1, and H is 2, negative 3, x2, y2. And then we put that in our equation, so we've got minus 3 minus 2 over 2 minus 4. Yeah, that's right. And that gives us minus 5 over minus 2, which gives us a gradient of 2.5. And then we've got D and F. We're going to find out if this is the same gradient as CH. So D, we've got negative 2, negative 3. And F, we've got 0, 3. Now these look like they might be parallel, but we're not sure yet. So let's find out. x1, y1, x2, y2. And so that gives us 3 minus negative 3 divided by 0 minus negative 2, which gives us 6 over 2, which is a gradient of 3. So that means that these two are not parallel because these are not the same. So what you do, once you've found out all of this, you've done your working, this is equal to m, actually, let's not do that. Let's put this down here. The gradient of AK is equal to the gradient of DG, because they both equal 1.5. This means that AK is parallel to DG. That's what that means. This means parallel, and then you said AK is parallel to DG. Now, these ones are not parallel because they have different gradients. Thank you for watching and good luck with your activities.